Integrating various forms of intelligence into a single, usable interface is a daily challenge for analysts within the DoD and the IC. By leveraging ArcGIS Enterprise, analysts can consume data from all domains to conduct advanced analytics, shortening the decision-making cycle and resulting in action over inaction. Within this section, the team will demonstrate the integration of open source intelligence data into a country brief. We will show advanced analytics in ArcGIS Pro to identify and locate bad actors in the South China Sea. And finally, integration of our analysis into a multi-domain, real-time, integrated common operational picture, enabling rapid decision-making through all echelons of command. Let us start by looking at China's standing in the South China Sea and how it affects other countries in the region. The dispute over the South China Sea began when China established the 9-dash line, claiming the South China Sea as Chinese territory. Recently, China has acted on acquiring resources, building up infrastructure, and aggressively policing the boundaries from others navigating in the area. Having the ability to leverage intelligence databases and integrate multiple data sources and sensors within my enterprise portal allows me to visualize the countries affected by the South China Sea dispute. Considering each country's economic zone within our map, we can see the geographic importance of the Spratly Islands, with its location in the middle of the South China Sea. This country brief displays adversarial tactics and patterns of life. This brief would be created by an analyst and utilized as a living briefing product. I say living briefing product since as new intelligence data becomes available, this product will automatically update. With the establishment of the 9-dash line, China has claimed territory over the Spratly Islands. This claim by China creates economic disruptions for neighboring countries and a power projection by China. Notably, within our map, we can determine that there are multiple trade routes within the region. If China continues to encroach in this area, there could be additional economic disruptions, not only in regional economics, but in global trade. Leveraging collaboration capabilities within ArcGIS Enterprise, we can discover available content like Jane's defense data, allowing us to shed some light on Chinese military and intelligence capabilities. With Jane's defense data, we can determine current land posture, air posture, and new air installations constructed on the Spratly Islands. I want to focus on Chinese naval capabilities under the People's Liberation Army Navy, split up between the North, East, and South Sea Fleet. Some known Chinese naval capabilities include numerous destroyers, frigates, and aircraft carriers, including the Knestov, acquired from Russia. To dig a little deeper, we can leverage ArcGIS Insights to visualize the location of Navy installations and see through an interactive display the order of battle of the Chinese fleet. Let us focus on the South Sea Fleet, where our link diagram shows that the fleet has a port at 4 installations. It's primarily undersea with an additional surface domain. As we go to the southern tip of China, we can see that at the Yulin Sonya base, there are 2 nuclear submarine bases where we can begin to take a more in-depth look. Drilling into Sonya, we can leverage existing analysis products, documents, and information shared with the entire organization for further analysis, collaboration, and coordination. Current intelligence has shown that the Chinese began construction on underground submarine bases beginning in 2008. Since then, the Chinese have increased their capabilities to include ballistic missile submarines. A critical piece of information needed is the current events in the region. These events need to include information on China, but as important is information on territorial disputes, government instability, and other activity, whether it's non-state or state action, and what patterns arise from this data. We can utilize this RGS Dashboard to get a better understanding of what contentions have been in the region as China progresses further south. One such contention is from the Vietnamese Foreign Ministry, which has protested against the Chinese Agricultural Ministry for imposing a fishing ban in the vicinity of the Spratly Islands. The last piece of Chinese influence in the region does not include official government personnel, but a merchant marine armada projecting Chinese power and influence. Recently, in the news, there has been information on various ships patrolling the Spratly Islands to include fishing vessels. That begs the question, have any ships delivered supplies to this island or other islands in the area? We can select these ships in the northeast and identify key characteristics of each, including the ship type, identification numbers, the names of their ships, and determine if any of them have been moving around the Spratly Islands. We can leverage information that we have gathered to create a query identifying where the ship has been and determining where it has been resupplying other ships and islands around the Spratlys. We can query our data based on MIMSI, or vessel identification, to see where it has been. We can also search our enterprise portal to see if any other analysts have already reconstructed the tracks of this vessel. The analysis output illustrates that this ship originated in China and traveled into our island of interest with stops in Hughes Reef, Pearson Reef, and Collins Reef. My results can be exported into a CSV or GeoJSON and shared for further intelligence analysis in ArcGIS Pro. Sometimes merchant ships turn off AIS tracking to avoid detection. If this vessel was to turn off the AIS, we could leverage Hawkeye 360 radio frequency data. Hawkeye 360 sends geolocations of RF frequency emissions with a confidence ellipse. Using this data within our GIS will fill gaps within our pattern of life analysis. Additionally, by combining Spire AIS data with Hawkeye 360, we can begin to build a holistic picture of activity in our AOR, of what ships want us to see and what they do not. In this section, we leverage a country brief from Jane's Defense data hosted in our enterprise portal. This data highlighted Chinese military capabilities and order of battle. We've also looked at tactical capabilities and marine merchant patterns of life around the Spratly Islands. Next, Parker Hornstein will utilize ArcGIS Pro intelligence to integrate multiple data types and identify additional bad actors around the Spratly Islands.
Thanks, Scott. As the number of data sources we receive and their volume increases, it becomes more important for us to find ways to normalize this data and find needles in the needle stacks. Space and time are the ultimate normalization, as everything happens somewhere and at some time. By adding our data to a GIS and using ArcGIS Pro Intelligence's robust analytical tools and new capabilities such as link analysis and link charting, we can comb through masses of data to find points of interest. Here, I am utilizing ArcGIS Pro Intelligence to analyze multiple data sources over the Spratly Islands to find potentially malicious ships. I've collected a week's worth of AIS, or Ship Automated Identification System data, for an area of 200 nautical miles around the Spratly Islands, and status from our partner Spire. I want to see how these ships are interacting with each other, so I'll utilize the ArcGIS Pro Intelligent Movement toolset. Specifically, we'll use the Find Meeting Locations tool. We can populate the interface with our track point data, the unique identifier, and a set of parameters for defining a meeting. Here, we'll define a meeting as two ships being within 2 nautical miles of each other for at least 30 minutes. In addition to finding meetings, we can simply find locations where vessels are dwelling for extended periods of time by using the Find Dwell Locations tool. Both of these tools utilize Spark distributed processing on the backend to allow for the processing of big data here in a desktop environment. We can see our dwell locations, here represented by purple dots. These are where individual ships are loitering. And the Detect Meetings location returns a series of meetings represented on the map, colorized by their duration. Let's change those to a symbol representing a group meeting. Now that we know where ships broadcasting AIS tend to dwell and how they interact, let's look at an analysis of Hawkeye 360 data to see where ships who may not be broadcasting are. Hawkeye 360 uses a constellation of small satellites to track RF or radio frequency signals across the globe. These signals can include ship AIS that is being broadcasted over VHF radio, or even just when a ship uses its radios to communicate. We can immediately notice that the Hawkeye 360 constellation has picked up more ships than there are broadcasting AIS over the same week period. To understand the patterns within this data set, I can utilize an optimized hotspot analysis. This tool will find statistically significant trends using the temporal aspects of my Hawkeye 360 data. The results show me areas of increasing activity, denoted in red, and areas of non-significant or decreasing activity in white and blue. We can filter our data down to just the areas of increasing activity and then use another movement tool, compare areas, to see how our ships with AIS are interacting in these areas. The hotspot analysis has shown significant area of activity where we do not have AIS tracks, meaning that there is an activity in this area that is going on in private, but we can detect it with our Hawkeye 360 data. The Compare Areas tool returns polygons representing every unique MIMSI that has passed through one of these areas, allowing us to see how ships that are broadcasting AIS are interacting in those spaces devoid of AIS. Now that we've identified areas of suspicious activity and correlated AIS tracks to these locations, we can step out to look at a larger pattern of life for the South China Sea using imagery. Utilizing the Visible Infrared Imaging Radiometer Suite, or VIIRS data from a NOAA satellite, we can look at trends in a different way. The VIIRS sensor captures the South China Sea at night, where the only infrared light measurable comes from ships using lights on deck for fishing or maintenance activities. This particular image on screen is an averaging of a series of images from September 2019. By using out-of-the-box image segmentation and classification techniques, we can generate point representations of every pixel with light in our image. Then by using our machine learning-powered cluster tool, we can identify groups of light that trend together and points that represent the noise in the dataset. Because this image is an averaging of multiple images over a time period, the resulting point clusters represent an average pattern of life for ships. And when we convert the point clusters to polygons, we can again run our Compare Areas tool to see where our AIS tracks are aggregating at night. Now that we've normalized multiple data sources, including AIS tracks, RF detections, and night imagery, we can combine them together and utilize the new link analysis tool to identify suspicious actors. I've already compiled a link chart of all of our data sets, the green dots representing countries, like this one, China. The red dots represent ship detections on AIS. The purple dots are dwell locations, or areas where ships stay for extended periods of time. When a line is drawn from one entity to another on the chart, it means there's a relationship, such as a ship visiting a dwell area. We can now use the new link analysis capabilities in RGS Pro Intelligence to measure the centrality of the network. By using a degree centrality measure, we can find which entities in this graph have the highest levels of influence. As expected, the countries are at the top, including China, Panama, Liberia, and the Marshall Islands. The latter three countries are known to be used as false flags when malicious actors are faking their AIS signals. When we move down our analysis, we can find several ships' MIMSIs, and when we examine one of the MIMSIs with a higher degree of centrality, we can see that it is a Chinese flag vessel that has visited several areas of interest and several dwell areas. We can see by the highlighted areas on the map that these meetings and dwells are in the Spratly Islands. And by using the Select Connected tool, we can see that within 1 degree of separation, this entity interacts with many ships moving in the main shipping lanes. Because this ship has a high level of influence in my area of interest and has activity both in the Spratly Islands and the surrounding shipping lanes, I'd like to place this ship on a watch list so we can more carefully monitor its activities in the future. To do so, I will utilize a Survey 123 form configured to automatically feed my organization's watch list. I'll populate the MIMSI of our ship of interest. The Survey 123 form is using a pull data capability in the backend to automatically find the last known position of this ship from our AIS feature service. I'll add an effective date of when I'd like the monitoring to start. I'll just select now. And when I submit this survey, we can automatically feed our collection services in our common operating picture to monitor and track this ship. In this section, we've reviewed how we can normalize multiple data types, such as ship AIS tracks, radio frequency detections, and night imagery by their spatial components and integrate them into a GIS. We've also examined how we can use ArcGIS Pro Intelligence to derive insights from this data using the robust analytical tool suite and capabilities such as link analysis. Now, we'll go over to John, who will showcase how we can integrate real-time GIS into our COPS to integrate the insights we've derived from our analysis and shorten our decision-making cycle.
In this section, I'll be showing an integrated common operational picture that brings together sources from across the organization and presents the information clearly. That way, all domain operations can be informed of alerts and threats and respond effectively. In this RGS dashboard, we have various feeds integrated from across the organization. This data includes live weather, NGA maritime data, like the World Port Index, bathymetry information, combatant information, military installations from Jane's Defense, merchant feeds from Spire AIS, and country boundaries and airspace. We have different widgets displaying the information as it comes in, helping us gain insight and inform how operations are going. Since this is an integrated dashboard with information across the enterprise, I'm seeing the watch list information that was populated by the watch list logger in the previous section. Here I can see the current watch list information and be able to merge that information to a real-time Spire Global AIS feed to see the current location of the vessel. It looks like this is designated as a Chinese Coast Guard vessel as broadcast by their AIS signal. By looking at the historic positions, we can see that this military vessel is posting up around the Filipino-claimed island, the second Thomas Shoal, which affirms claims that China is projecting power in the Spratlys. Now, it also makes sense that the link analysis has confirmed that this ship with large amounts of meetups, as this vessel could be harassing other nations' vessels. We can see the current location and the recent locations of the vessel. We also see millions of records and how it compares with normal traffic patterns in the region. It's located here. As we move around, the map is updating. So we can see the port information here with large amounts of data. And we can see there's traffic patterns through the Spratlys. We could use this to notify where we can post up Blue Force or partner nations to monitor shipping traffic in the region. If we were going to respond to this Chinese vessel restricting navigation and showing force, we would want to consider the effectiveness of operations based on the weather. This tab presents a dashboard of live weather analyzed to see the effectiveness of different mission types, with green being favorable while red being unfavorable. It looks like in Southeast Asia, there's a lot of rain and clouds. This may affect UAV operations in our area of interest, so we may want to use a different platform to conduct our mission. Real-time news information is also important, as it could give commanders a pulse on current events that could be affecting the operations. In this dashboard, we're using RGS GeoEvent Server to ingest news articles from GDELT, a project monitoring the world's news articles. Here we are searching anything that mentions or relates to the Chinese Navy, South China Sea, or Spratlys. In this easy-to-use dashboard, this shows us the news article's location and date of publication. We can interact with the chart by date, then by location, and see features. Here's an article from a Chinese news outlet describing how the USS Reagan has entered the South China Sea on the 18th of October. In the main COP, we can see various tactical feeds being ingested by GeoEvent and some alerting done as units meet the certain conditions. The left-hand side describes combatants, describes clearly the type of units with high interest, red forces at the top and blue forces at the bottom. Each item can take us to the location to see what's around the unit. In this section, they have the in-zone parameter, which describes a named area of interest. GeoEvent is using a geotagger to populate this field. This is useful as it drives widgets like this chart describing what named area of interest the units are in. Above this widget is the named area alerts widget. This describes when blue units enter enemy territory. This location describes when the Eagle 10,000 Blue Force ID entered the claimed Chinese air defense identification zone of the East China Sea and shows where the track was in the area. It has now left the area and is navigating to the northeast. This type of widget is useful as it allows commanders to understand the length of time units spend in red force areas. The red alerts in the alert zone widget define major events when blue forces come close to an enemy, and this could include interdictions, close approaches, or when blue forces are within arm's range of an enemy's capability. This alert event here describes when enemy aircraft approach a blue force marine reconnaissance aircraft. Since this dashboard supports a joint multi-domain mission, we've extended our analysis to the space domain, where we are viewing the two-line elements or orbits of the Chinese Yaogan military satellite constellation. This is useful to understand where the satellites are and when they will be in RF range and whether they pose an intelligence risk to our forces. In this overall presentation, we have shown how we can support an all-domain mission by bringing in various pieces of intelligence and showing how they can support operations. First, we showed a country brief presented in story map form, showing how China has developed interest in the Spratly Islands. Secondly, we showed how we can understand entities of interest with RGS Pro intelligence. And finally, we showed a dashboard supporting all domain missions with clear to understand widgets supporting informed decision making.